All right, so next one. The position function of a particle is s is equal to all of this, where t is greater than or equal to 0, where t is measured in seconds and s in meters. Now this is kind of a funny one because we never did this in physics, did we? But in calculus, distance is quite often used with the symbol s. Okay. I'm not exactly sure why, but I have a feeling it's because writing, if it would have been d, right? Writing dd over dt is a little awkward, right? It's better to like think about this thing as being like ds over dt, right? You can kind of see more clearly that the d's were kind of like our change in symbols, but yeah, so I think it's just to avoid confusion in calculus. Okay, so either way, we've got kind of a funny situation here, right? We've got a cubic function going on, so it's not going to behave like a standard parabola like in the last one, right? So in this case, when is the particle at rest? So, okay, we can figure out when it's at rest when the velocity is equal to 0. Okay, so step number 1, I got to figure out an equation for the velocity of this function, which means I got to take the derivative. So let's find, v, which would just be equal to ds dt, derivative of s with respect to t, which is equal to, and then the derivative of this would just be 6t squared minus 24t plus 18. Okay, so now looks like we'll set it to 0. And at the same time, why don't we factor this, make it look a bit nicer too. So 6 is common to all of these, so I'll factor a 6 out. So 6t squared minus 24t, or sorry, not 24 now, minus 4t plus 3. Okay, and then we'll just factor. And we get t minus 3 and t minus 1 for our factors there. So then this is going to happen at t is equal to 3 seconds and 1 second. When is the velocity negative and when is the velocity positive? Now, thinking in the last unit there, when is it positive and when is it negative? All right, so just for a second, we've got like a cubic function. I don't really know what's going on yet, but let's say it does something like this, right? Starting low, ending high. When is it positive and when is it negative? Isn't this really saying areas of increase and areas of decrease, right? Like when is the derivative, when is the slope of the tangent positive, and when is the slope of the tangent negative, right? When is it positive and when is it negative? That's really what's being asked here, right? So, okay, we're going to do a method similar to what we did in the last unit then. So, what I'm going to do, I'm going to make a number line. I like the number line method. You could use the chart method here too if you prefer that one. Okay, and I'm going to write down my critical numbers here, right? So this would be at 1 second and at 3 seconds. And I'm going to write down my equation for velocity. I'm going to write it in this form. I'll say v was equal to 6 times t minus 3 and then t minus 1, right? Oh. Okay. This form's nice, like the factor form's nice, is because I can kind of look at these parts independently now too to figure out whether the thing's going to be positive or negative, right? So let's throw in 0, right? We'll check the value 0 for this section to see what comes out. So here, I'll say the velocity too, to remind myself here. So when it's 0, then if I threw 0 into this would be coming out negative. This would be coming out negative, right? So 2 negatives, that means it's going to be positive in this section. So positive velocity before a time of 1 second, right? And to tell you the truth, I've got this arrow going all the way to negative infinity there, but really, we started at a time of 0, so that's what I really care about. So it's positive from a time of 0 to a time of 1 second, okay? Then moving over from 1 to 3, so I'll throw 2 in there. So if I threw 2 into this function, then that's going to be, well, 2 minus 3, so that's coming out negative. And then 2 minus 1, that's coming out positive. So it's going to be negative in this section. And then after 3, I'm thinking they're both going to be positive, right? So that thing's coming out positive for sure. And then there you go. So there's our areas of increase and our areas of decrease. So I kind of cheated. I already kind of knew like a little bit what it was like. All right, so let's write this out now. We'll say that the velocity, so v, is positive on the interval of 0, it'll be including 0, because we did start at 0, right? So time 0 does count, and it was positive even at 0 there, okay? It was moving at that point already, right? It didn't start from rest, which is a common mistake. Okay, so anyway, so from 0 to 1, but not including 1, because at 1 it stopped, right? Those are our 2 points that the thing stopped moving. Right? It's at rest at 1 and 3, so it doesn't include that. It doesn't have a positive velocity because it's not moving at all at that point. So anyway, so 0 to 1, unioned with, and then same thing for 3, doesn't include it, and then to infinity. Okay, and then v is negative from, well, in between 1 and 3. Okay. Draw a diagram to illustrate the motion of the particle from 0 to 5. Okay, so let's do a rough sketch. So we'll say, so this will be distance time still. It'll be helpful to draw in our numbers here for 1 and 3, because we know this is where our graph is either going to come to a peak or come to a min, right? Okay, so yeah, those are our numbers. So what we're going to have to figure out here then is kind of, when I throw in 1 and 3, what are the distances associated with those positions, right? So let's figure those out. So for a time at 0, 1, 3, and then we'll do 5 as well because it's from 0 to 5, right? And that should give us a pretty good picture of what's happening here. So if we plug them into the original equation, right, into the original, then s of 1, s of 0, let's do them in order. S of 0 would be equal to 0, which makes sense. That's our y-intercept, right? Okay, so we have a point right here. Okay, s of 1 would come out as, maybe I'll show you what that would look like too. So that'd be like 2 times 1 cubed minus 12 times 1 squared plus 18 times 1, and that comes out as 8. All right, so at 1, it's coming out as 8. So let's say 8's around there. And then we'll throw in s of 3, and that comes out as 0. So at 3 seconds comes out as 0. And then s of 5 comes out at 40. All right. So then, yeah, so 5, I didn't write it on there. Okay, so 40, so yeah, it'd be like way up here. Higher, but yeah, good enough. Okay, so then in the end here, we know that, well, okay, so it's starting here. It's increasing in this section. We figured that out before. Must come to a max here, right? We knew that the velocity was 0 at that point. Okay, so then and that comes back down. And then same here. We knew that this was a min right at 0. And then goes up to 5. So that would be in that section there. Okay. What is the total distance traveled from 0 to 5 seconds? Okay, so now notice the keyword distance. All right, so distance means that we don't care about the direction, right? So this one, especially now that we have the graph made, it's pretty straightforward. All all we got to do here is just go, well, it's 8 up and down, right? You went 8 from there to there. And then we had to go, like in this section here, we know that we went down 8. But again, I don't care about the direction, so this is just 8 plus 8. And then from there, we knew that we went up, what was it, 40. Okay, well, that's just 8 plus 8 plus 40 is equal to 56 meters. Now, if you didn't have the graph and a bit more mathy, we could do these in sections, right? Where we could say from a time equal to 0 to a time of 1, then it would really be the absolute value of s of 1 minus s of 0. I'll explain what this means in a second. Okay? And then, which would be equal to the absolute value of 8 minus 0, which is equal to 8. Okay, what I did there was really just figuring out the distance from here to here, right? The up and down. We just went our height, right? S of 1 was how high you were here, minus S of 0, which was your beginning, which was just 8. And the reason why it was the absolute values is because I don't care about the direction, right? In this case, the absolute values didn't matter. It would have been the same either way. But in the next one, if we go from an interval of t at 1 second to t at 3 seconds, then that would be s of 3 minus s of 1, absolute value bars, which ends up being 0 minus 8, right? Because that's this height minus this height, which comes out as a negative number. But I didn't really want it to be a negative number because I don't care about the direction, right? So this would be 8 again. Okay? And then the last one for the last section, T3 to T of 5, or T is equal to 5, then that's going to be S of 5 minus S of 3, absolute value, which is equal to absolute value of 40 minus 0, which is equal to 40. And then we'd add them all up, right? So, but we just knew that from the graph, right? We could just kind of see that.